Okay, so what you're going to be learning today is Unit 4, Lesson Set 9. It matches 5-9 in your workbook, and it is about accident investigation data. So you're going to be able to determine the maximum skid speed using the skid mark formula and determine the maximum skid speed using the yaw mark formula. So a couple of vocabulary words. So when we're talking about a skid mark, we're talking about a mark that a tire leaves on the road when it is in locked mode. So when what that means, locked mode, is that you've applied the brakes and you've locked your brakes. A shadow skid mark, this is when brakes are first applied to the skid mark and it's light and it darkens until the car comes to a stop. So when you press your brakes hard, at first the skid mark is really light and then it darkens the more it puts on there. And yaw marks, these occur when the vehicle is slipping sideways while at the same time continuing a forward motion. So the tire marks appear curved on those. So there's two types of way of getting data. So the first one we're going to look at is the skid speed formula. And that is S equals the square root of 30 times D times F times N. Okay, so D, that's the skid distance. This is the number and lengths of the skid marks left at the scene. So when you do a skid distance, it's going to be an average when you find them. Okay, it's an average. So if you have 3 skid marks that are 75, 75, and 75, it's going to average out to 75 because you would add all 3 75s and divide by 3. But that is how you figure out the skid distance. The speed, that's how fast the car was going when it entered into the skid, and that's what we were finding out with this formula. The braking efficiency, okay, so this is determined by an examination of the rear and front wheel brakes. It's a percent that is expressed as a decimal in the formula, because remember, you have to change percents to decimals when you're using them in math. And it can run from 0% efficiency, which means you have no brakes at all that are working, to 100% efficiency, brakes are excellent condition. And drag factor, I don't know if it was this class, but drag factor is the pull of the road on the tires. It's the friction. So the different road surfaces will drag on the car more or less. And here are some of the various drag factor ranges for cement, asphalt, gravel, snow, and ice. In the problems, they will give you the drag factor and they will give you the braking efficiency also. But these are things that accident reconstructionists figure out and determine when they're looking at accidents. So the first example, a car is traveling on an asphalt road with a drag factor of 0.78. So there's one piece of information. The speed limit on this road is 35 miles an hour. The driver just had his car in the shop and his mechanic informed him that his brakes were operating at 100% efficiency. The driver makes an emergency stops and leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed the car was traveling when it entered the skid? Round to the nearest tenth. Was the driver exceeding the speed limit when entering the skid? So first thing, get our information. Distance, so that means D is 80. And just a reminder, we're using this formula, S equals the square root of 30 times D, F, N. Drag factor, that's our F factor, is going to be 0.78. And our efficiency, because it's 100, it's going to be 1, because 100% is equal to 1 in decimal form. Also, distance, the reason I didn't do the average here is because if we take and add 80 4 times and divide it by 4, we get 80. Okay, but if you have problems that have various skid mark lengths, you need to add them together and divide by the number of skid marks there are. So at this point, all we have to do is plug into our formula. 30 times 80 times 0.78 times 1, find the square root of that answer, and we get 43.3. Now keep in mind, at this accident, the speed limit on that portion of the road is 35 miles an hour. And according to the accident reconstructionist, the speed that car was traveling was 43.3. So the car was traveling 43.3 miles per hour. The driver was exceeding the speed limit and could be fined. Just a reminder, when you're doing problems, sometimes instead of listing miles per hour like I did with mile/hour, could also be written as mph. To represent the miles per hour. In the second example, Melissa was traveling at 50 miles an hour on a concrete road, so has a drag factor of 1.2. Her brakes are working at 90% efficiency. To the nearest tenth of a foot, what would you expect the average length of skid marks to be? And she was traveling at 50 miles an hour. So in this case, we're looking for the D. We don't know what the skid length is. Okay, so the skid marks are the D variable. What we do know is we know the speed is 50, so S equals 50. We know the drag factor, F, is 1.2, and the efficiency is 90%, so that means it's 0.9 for our formula. So in our formula, just like before, we're going to plug everything in. The only difference is we're going to be looking for the D here. We're going to be looking for the D variable. So we're going to plug in everything else but the D. So 50 equals the square root of 30 times D times 1.2 times 0.9. And we solve for underneath and we get 3.24D. Don't forget that to undo a square root, you square both sides when you solve problems like this. So when we square it, we end up with 2,500 equals 32.4D. So the answer is 77.2. So that tells us that the average length of skid marks with using the given conditions would be 77.2 feet.